So you may not have ever wanted to know this answer, but we're going to answer what is the term structure of interest rates and what is a yield curve. So the term structure of interest rates is the relationship between interest rates, or they're also called yields, and maturities of securities. When this relationship is graphed, the resulting curve is called a yield curve. In this example, you can see three different yield curves. We usually would assume that most yield curves would be upward sloping. However, we have three different examples. Notice that the interest rate is here on the y-axis and the number of years to maturity is on the x-axis. Also, look that we can define short-term versus intermediate term versus long-term securities. The top blue line is an inverted yield curve. It is one that is downward sloping, and it's back in 1980, the example, where you could get 14%, which is amazing, on really short-term debt instruments. So my savings account, if I would had any savings at 1980, I could have made a lot of money. But anyways, as you look along the yield curve is downward sloping so that the longer term securities are even still great at like a little bit above 12%. Now, this was great in terms of investing, but if you think about if you had to borrow money, you would have to get a much smaller house because you couldn't, to pay 12% interest, you just can't get as big of a house. And that you need a huge house, but compared to what we have today, like 4%, it's a drastic difference. And then we have for the year February 2000, the yield curve is just kind of almost flat. So that's kind of what we would call this as a flat yield curve, the pink line. And then 2013, we see our depressing interest rates, basically zero, like I was talking about before, but it's upward sloping. But even if you go out to 30 years, and these are for treasuries, the most you could get is like 3% or 3.4 or 3.5%. Notice on this graph that we have not mixed in corporate bonds with these treasury bonds. If you make a yield curve, you are just graphing all treasuries if you're making a treasury yield curve. If you're making a corporate bond yield curve, you only graph corporate bonds, but that gets more difficult. If you're graphing corporate bonds, you have to divide them into their ratings by like Moody's and S&P. So all AAA bonds, corporate bonds, have to be on one yield curve, and then all triple B yield or triple B rated bonds have to be on another yield curve. So just notice here that we are only really talking about treasuries for these yield curves, and we don't mix other types of bonds in when we're making this type of graph. Now let's look at how we can calculate inflation. So inflation, this looks like a complicated formula, but really it's just saying it's calculate an average. If you have the expected inflation rates for the future years, add them up and divide by the number of numbers that you have. So it's just a regular average. And here's an example. So if you have, let's see, three numbers, well, I'm sorry, assuming inflation is expected to be 5% next year, 6% the following year, and 8% thereafter, we can calculate an average rate of inflation if we're looking at 1-year inflation, 10-year inflation, and 20 years. So this information down here was important because they just said 8% thereafter, and that could be infinity. But if we look down here, we see we'd need 1-year, 10-year, and 20-year. So the average inflation rate for 1 year, if it's going to be 5%, will just equal 5%. The average inflation for 10 years is 5 plus 6, plus 8% times the number of years left to make 10. So there's 8 years left. So 8% times 8. That's the same thing as adding 8% 8 times. So this sum divided by 10 is equal to an inflation rate for 10 years of 7.5%. And then the inflation rate for 20 years, we're going to do the same thing except have an 18 here. And take the average, and we get 7.75%. Keep in mind that these are pretty high inflation numbers, especially 7.75%. Just for you to be able to break even with inflation, you would have to earn, at least for 20 years on a 20-year investment, 7.75% plus what you need to earn for the future, like for your retirement, based on this example. So if you only earn 8% over that 20-year time period, then your real purchasing power only increased by 8 minus 7.75, which is equal to 0.25%. And that would be very sad. That's less than my savings account rate. So just keep in mind, but this is just an example number. Most people agree inflation is around 3% per year. So, but you still have to take that into account and add that into your expectations about what you need to retire in the future. And again, this is another plug for you to start investing today because you are all young and have so much time to have your money grow. So the maturity risk premium, this is just showing you an example. They've made up an example calculation formula to be able to figure out what you should add as maturity risk premium. And so they've just said, well, let's take the number of years minus 1 times 0.1%. So we're going to use their made-up equation to look at the same examples for a 1-year, a 10-year, and a 20-year debt instrument. So the maturity risk premium, if it's just a 1-year security, is only 0% because there really is no maturity risk premium. For 10 years, it's 0.9%, and then 20 years, it's 1.9%. The maturity risk premium should always increase as time increases. Also, keep in mind that the shape of the yield curve depends primarily on 2 factors. 1, expectations about future inflation, and 2, the relative riskiness of securities with different maturities. If you see a yield curve that is upward sloping, this is due to increasing expected inflation and an increasing maturity risk premium. And then if you saw a yield curve that was downward sloping, that would be due to decreasing expected inflation and a decreasing maturity risk premium. And if it's flat, then you expect no change in inflation or the maturity risk premium. So here we're going to take our numbers that we had, and they say assume that R star, the real risk-free rate of interest, is 3%, and we're going to add the inflation premium and the maturity risk premium. Since we are only adding the inflation premium and maturity risk premium, we know that we're trying to figure out the yield curve for a long-term Treasury, because if you looked back at that slide with the chart of what you should add for each short-term, long-term Treasury, and then short-term and long-term corporate bond, you'll see that this is the equation for a long-term Treasury security. So these were the numbers we just got. Remember, the inflation for a 1-year Treasury was 5%, and then the maturity risk premium was 0. So we get 8% for a 1-year Treasury, which that would be great. A 10-year Treasury is 11.4, and a 20-year long-term Treasury is 12.65%. And then if we were to graph this, we would see that 3% is that constant real risk-free rate. The inflation premium increases over time, with our example from 5% upwards to 7 point something percent. And then the maturity risk premium was 0 at first, and then it went up over time. And so this blue line gives us the final yield curve. It shows us that it's upward sloping. Here we're just looking at the relationship between Treasury yield curves and yield curves for the corporate types of bonds. And the corporate bond yield spread, if you look down here, is equal to the corporate bond yield. If we looked out in the market on Bloomberg right now and said, what's the rate on AT&T 30-year bond? If we subtracted the Treasury bond yield, then what we would have left in terms of that equation is the default risk premium plus the liquidity premium. If you were trying to get a corporate bond yield, then you could take the Treasury bond yield and add the default risk premium plus the liquidity premium. And this is just because the corporate bond is not going to be liquid like the Treasury bond yield, and the corporate bond has default risk. The company can go bankrupt. One thing to also remember is that the spread between a corporate yield curve and the Treasury yield curve widens as the corporate bond rating decreases, and it's equal to the default risk premium plus the liquidity premium, like we were just talking about. Keep in mind that what I mean when I say that the spread, or that means the difference between the corporate yield curve and the Treasury yield curve, widens as the corporate bond rating decreases, is because when a corporate bond rating decreases, that means it's getting closer to a lower quality bond, and that company has to pay more interest expense. It'll have a higher, interest expense rate than other types of companies. And so that would make the difference between the two larger. Here are some example rates on 5-year bonds in February 2013. So we have U.S. Treasury is equal to 0.83%, a AAA corporate 0.93%, all the way down to an A, which is a lower rating than a AAA, of 1.67%. And we're just seeing that you could back out the corporate bond yield spread, which is always equal to the default risk premium plus the liquidity premium, by taking 0.93 minus 0.83. That difference is 0.1%. So the sum of these two equals 0.1% for a AAA corporate, and for a AA corporate it equals 0.46, and then finally 0.84 for an A corporate. And then here we have an example yield curves. Like I said before, Treasury yield curve for the Treasury bond, all of these are Treasuries plotted along the red line. For AA rated bonds, all AA rated bonds are plotted along the green line, and BBB rated bonds are the last category for investment grade bonds, and they are plotting above all of the different yield curves. So a Treasury bond is safer than a AA rated bond, which is safer than a BBB rated bond. So you can see how the graphs, the interest curves are going up based on the riskiness of the bonds that are being plotted in the yield curve. And then you can also see that the spread between corporate and Treasury yield curves are, well, the Treasury yield curve is always lower than the corporate yield curves, but they're not always necessarily totally parallel to the Treasury curve.